A problem like this can be a little challenging because of two things. One is that you must use the half-angle identities to solve it. An answer that's found using the sum difference identities, even if it's a correct answer, is going to be marked wrong because I want you to prove, at least for now, that you can use the half-angle identities. Second thing that's difficult, I need exact answers. Okay, no decimal approximations. So in other words, you might as well just put that calculator away. It's not going to help you here. I need exactly correct answers using the identities. So let's walk through that for sine of 247.5. Now, if you remember the half-angle identity, the sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta all over 2. That's the identity we're going to use. So you can see that what's important to figure out is what is this theta thing? Well, if theta over 2 equals 247.5 degrees, then that means that theta, if you multiply both sides by 2, theta is going to be equal to 495 degrees or so, I think. Okay, so 495 degrees, that means sine of 247.5 degrees is going to be equal to plus or minus the square root of 1 minus the cosine of 495 degrees over 2. Well, not many people know what the cosine of 495 degrees is, but many people know what coterminal angles are. Okay, and if this is my unit circle, and I say, where's 495 degrees on it? Clearly, it's more than 360. So we can just drop 495 down by 360, and we get 135. Now, most people know where that is on the unit circle. That's over here. Okay, that's 135 degrees like this. So this becomes equal to plus or minus the square root of 1 minus the cosine of 135 degrees over 2. Okay, great. This is real progress. Now, I hope you know what the cosine of 135 degrees is. That would really help. That's going to be equal to the square root of 2 over 2, because this is in the second quadrant. That's going to be negative. So as I simplify this answer more and more, now I've got 1 plus the square root of 2 over 2, all divided by 2. I haven't simplified this very much. I can do that in a moment. I want to talk about this plus or minus right here, because that needs to be addressed. This guy is the source of so many mistakes when dealing with the half-angle identity. The way we determine whether we use plus or minus is by looking at the angle in question. It's not 135 degrees. That's not the angle I care about. This is the angle I care about, 247.5. Well, where is that? If you think to yourself, okay, it's more than 180, but it's less than 270. That means it's somewhere over here. Okay, this is where 247.5 degrees is, somewhere in quadrant 3. And that means this is going to be a negative answer. And if I wanted to simplify that thing, I'm going to say 1/2 plus radical 2 over 4, although the homework problem should accept any answer that's unsimplified as long as it is an exact answer. Okay, so this would be my answer for that first one. Now, in terms of the other ones, cosine and tangent, how are those going to be different? Well, not a whole lot. They use different identities, but the reasoning that you go through is going to be exactly the same. So if I'm just going to write the identities for you quickly. I don't have a whole lot of time left in this video to go through it, but the equation you're going to use for a cosine problem is just this. It's 1 plus cosine theta over 2, so it hardly changes anything in the reasoning. Your answer is going to have a little bit different plus sign to it. And then tangent theta over 2 is simply sine over cosine, which if you work through the algebra is going to come out to this. You get 1 minus cosine theta divided by 1 plus cosine theta. Okay, so otherwise everything else is going to be the same except that particular formula.